Hey everybody, it's Michael. Welcome back to Mind Machine Interface. We solved a couple of puzzles here. The screen reset, which was just drawing the screen with white pixels. The calibration test, which we drew a test pattern on screen. And now we have the hue corrector, which we looked at briefly last episode. Just a note though, looking at the Steam Greenlight page, I see that one of the features is translate an alien language, or learn to read an alien language. So I guess we can actually maybe figure out what all this means. Now, I have a very, very minor background in linguistics and cryptography. I don't know that that will help me, but I might take a stab at it at some point. But let's go back to the hue corrector here and take a look at it. And actually, I had already done a little thing at the last episode, but if you didn't see that episode, let's explain what's going on here. So we're going to get counters out of here. If we just fed them right into the input slot over here, can I do that by disconnecting this and drawing a line? Yeah, let's try that. Yeah, so we're just going to send one counter over there. If we were to make a little loop like this guy here, we would send white counters and fill up the screen with them, which is not what we want to do. What we want to do is get all the pixels from up here and put them down here, but then we need to color correct them. So we're going to turn red to cyan. We're going to turn cyan to dark blue. We're going to leave white alone. And is that it? Yeah, I guess there's only 3 colors. So, yeah, that's what we'll need to do. Oh, no, there's 4 colors. Oh, we got to turn blue to red, right. So this little gadget that we built last night, it puts out a counter. It goes down to here. The 0 one, the first one through, gets split off, duplicated before a 1 gets added to it and sent through. And then we start a little cycle here where we're going to increment the counter every time and keep popping them down to here. Now this gadget here is our printer. It prints the counter with the color of the pixel at that coordinate from the upper screen. So we're addressing them here. We're putting an address on the counter here, and then we're going up and saying, okay, what is the color at whatever address we're at from this screen, and then we're passing it in up here. And if we look, you'll see that we're not getting any matches until we get to white, but we are in fact getting the color from the screen at the top and putting it down below. So what we need to do now is color correct, and how do we do that? I don't know. This is the color sensor. We can change its color. Red detects red counters, blue detects blue, cyan detects cyan, activates the arrows of the condition met in the entire grid. Black arrows are activated only if the sensor has no color. Okay. I don't know what that means, but let's drag it onto the screen here and have a look at it. So what do you do if we color a U? Okay, I don't want that there. Let's get rid of that. If we were to put a 1, so that'd be red. Okay. So we can actually turn on all 3 colors there. So in theory, we could send this out multiple directions. Okay, let's move our counter back up to here. Let's see, let's get rid of that. We're gonna drag this counter, this little adder up to here. Actually, you know what? Here, let's just delete this whole thing. And push things back this way so we make sure we have enough room. So we want to bring a counter out of here, and then we want to get it added up. So what can we do about that? We can, well, I think we got to bring it down 1. I don't see any way to build a loop in that smallest space up there. But we should be able to put that there and put a 1 on it. Okay, and now we can take a counter out of here with a duplicator arrow, and then we can just run this around like that. So now we should get our increasing counters. Yeah, we do. Okay, that's good. So there's our increasing counters, and now we need to grab the right color off of the screen. So that's going to give that to us. And if we were to put a 1 here, let's see. Red, 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 cyan, cyan, cyan. Or no, it's not coloring it. Well, actually, that number is just running up really fast. That's the key piece. But we can, okay, we can sort this out. Let's just put it down here like that. Are you going to send us those colors? Yeah, you are. All right. So now we're reading, successfully addressing the counter, reading the color off the top of the screen. We need to do something with it. So let's try this sorting block here and see what happens. So we can take 3 arrows off of this thing. Do we need like 2 of them maybe? Because the reason is there's a white pixel too, right? We got 3 colors we need to convert, but we also have a white pixel. So I'm not sure if we could do that. I mean, we could do like multiples like this. Let's see how this works. If we just push them from here to here, we make this guy a red, blue, cyan, like that. And if it doesn't get through any of that, it'll be white and it'll go in. Right, okay. I think this is going to work. Let's try and see what happens. So we take this printer here. This is going to change the color for us. So we want to turn red into cyan. So like that. Now I'm probably going to have to work on timing here, but let's try this. So in theory, no, it doesn't seem to have sent any red pixels that way. Oh, because this is supposed to be red, isn't it? There we go. Okay, so we got the cyan pixels right. Let's try this one. We're definitely going to have a timing issue. At least I believe we're going to have a timing issue. So we make that into blue. And I'll try to draw it in there. I don't think it's going to work though. Aren't there any blue pixels? Oh no, there aren't any blue pixels for a while, so never mind. This needs to be, by the way, blue needs to convert to red, so let's do that. Let's take cyan, because we're going to need cyan. So cyan is going to convert to dark blue. And we need to make this be a cyan arrow. Right. And this should be whites. Okay, let's try this. Alright, that's converting properly. We're getting matches there. Okay, we're not getting whites. So let's take whites over. Maybe they won't actually collide here. Okay. Alright, now we can press and hold F3 to speed up. Oh, what? Okay. Test 4 of 4 completed. Wow, alright, I didn't mean to cause all that to happen, but have we really solved the rotation module? We have not done that, right? No, okay, we've only done 3 of 35. Wow, okay, well that was so weird. Let's go back to that. And let's try running it again. Wow, okay. The puzzle was a little easier than I thought it was going to be, frankly. I thought we were going to do a little more with it. But there's no timing issue because we're sending these things out individually. So they're not running into each other. So, okay, so wow. Alright, the developer said press F3 to speed through the test. There must be multiple tests going on here. There must be 4 pages of tests. Let's try this again. I'm sorry, the whole thing just took me by surprise. I didn't think it would speed to the end. I thought it would just sort of speed things up. If we start this, right? And I'm going to try to watch what is happening here. So we're going to blaze through this puzzle, blaze through that puzzle, blaze through that one, blaze through that one. So there's 4 tests to do. We solved them all. We just didn't get to see it because it was too fast for the human eye. Alright, that's fine. We've done that. So what the heck is the rotation module? Let's take a look at this. So we need to turn it upside down, basically. No color correction going on. Alright. What kind of new tools do we have here? We have a negator to reset the counter's value to 0. This is the subtractor we've already seen. This is an inverter, negates the counter's value. And this is a sync. Press 1 to 5 to change its color. It locks the counter until at least 2 counters are on at least 2 syncs of the same color. Fuchsia arrows are not affected by sinks. I'm not entirely sure I would know how to use that at the moment. Okay, we'll have to play with this. So let's just play with these gates here, and we'll probably call this a short episode. So, if we just take a counter out of here, let's just try 639 here. 639. So we're going to take this initial counter, we're going to add 639 to it. And then bring it into here, and then drop it here and take a look at it. Is it going to be negative 639? It is. Okay, so it's going to be negative 639, so that really does mean negates. Color sensor, we already know about. We already know about the printer. Sync. Press 1 to 5 to change its color. Locks the counter until at least 2 counters are on at least 2 sinks of the same color. Okay. I don't know how that plays in. And then a negator resets the counter's value to 0. Alright. It does what it says on the tin, for sure. Well, I'm very curious how we are going to do this. It almost seems like we're going to have to... Let me think about this for a second, right? So we want to take pixel 0 up here and make it be pixel 639 down here. So that almost seems like we need to start with... We need to start with the actual value to read the screen up here and have that be a counter that counts up to 640. But then it also seems like we want to maybe... See if this makes sense. Duplicate this counter as it's going around, and in addition to going and then reading the screen color up there, that we need to split off whatever the count is over here and have it affect a thing that would flip it into 639 minus the original value. But how can that happen with the things that we have? This sounds like it's about color, which I don't know how that would affect, and this resets the counter's value to 0, which is not, I think, super useful. Well, let's get a loop. Let's at least start reading the pixels, right? And we can see what happens then. So, bring it out into here. Go with the same situation we had before, I guess, where we're just taking it around and adding 1 to it each time. And we'll duplicate it off over here. Read the screen color. So now, in theory, this should just copy the upper screen to the lower screen. Is that what's going to happen? Yeah, that's what's happening. So we're not getting matches. Okay, so at some point we have to basically subtract this counter's value from 639. How do we do that? You got me. You got me. I don't exactly know. Is there some way that we can, like, add or subtract 2 counters? Is that what this is about? Locks the counter until at least 2 counters are on at least 2 sinks of the same color. No, it's about comparing color. It's not about comparing value of the counter. We need a way to compare counter value, at least as far as I'm understanding this puzzle at the moment. Interesting, interesting. Well, let me think about this one for a while. We'll come back next time and we'll take a look at it. But until then, I hope you guys are, if you're playing the game, I hope you're enjoying it. If you're not yet playing the game, check the link below for a link to the Steam Greenlight page where you can download the demo for yourself and give it a try. So, talk to you guys soon. Bye.